What's going on, Algebros? Welcome to another video where we are talking about continuous interest, where we want to figure out how long it takes to double an investment that's earning 6% APR compounded continuously, and there being an initial investment of $500. So we want to figure out how long would it take for $500 to double. So I'm going to make out a list of the variables involved in the formula for continuous interest because it does have that keyword in the instructions, continuously. So A, P, R, and T. So you got to be careful. It says how long will it take to double the investment of $500. So this $500 is actually a value of P. And after the value of T that we end up getting as our answer, we want this 500 to double. So where it says double the investment, this is talking about a value of A that's 2 times the principal. So in this case, the value of A is going to be 1,000. The rate is 6%. Of course, we want to use 0.06 instead. And the amount of time, T, is an I don't know for right now. So keep in mind it wants us to figure out how long, so we're not really sure what T is. But what we could do is plug all this information into the formula for continuous interest. We know that A is going to be 1,000, P is 500, E is E, and the value of R is 0.06. That's getting multiplied to T. So the crux of the problem really boils down to solving for this T. And what we have at our hands right now is actually an example of an exponential equation that we need to solve. And so we're going to kind of take a trip down memory lane. One of the first things you want to do is isolate the exponential expression. And we can do that by dividing each side by 500. Okay, so that gets rid of the 500 that's in front of the exponential expression. And if you're alright with it, I'm actually going to change the left-hand side to e to the 0.06t. And the right-hand side, we know that 500 is going to go into 1,000 2 times. Now keep in mind, t is in the exponent here. One thing that we can do to get t back down on the ground, so to speak, is to take each side and plug it into the natural log function. So that's the natural log of e to the 0.06t equaling the natural log of 2. Now why I chose to use the natural log function is because the natural log and base e are going to cancel each other out, and that's going to bring 0.06t down onto the ground and set equal to the natural log of 2. Divide each side by 0.06, and we're looking at a t value of the natural log of 2 all over 0.06. And as a more practical answer, if you plug this into the calculator, that's roughly 11.6 years rounded to 1 decimal place. So if you want to double $500 under these conditions, so where the rate is 6% and it's compounded continuously, we need to wait just over 11.5 years for that to happen. Okay? So that's where this video is going to end. As always, thank you for watching, and if you have any questions for me regarding the content, feel free to let me know. Otherwise, have a good one, gang. I appreciate